In question 6, the function f is defined as f of x equals to x square minus 4 upon x square plus 4 for x greater than 2. We have to find an expression for f inverse. So to find f inverse, we first write y in place of f of x. In the next step, we'll exchange the values of x with y and y with x. So this will be written as x equals to y squared upon 4 upon y squared plus 4. Now we have to make y the subject, so we'll cross multiply. This will become xy squared plus 4x is equals to y squared minus 4. Taking 4 on the other side, we'll get 4x plus 4 is equals to y squared minus xy squared. Now taking y squared common on the left hand side, we'll get 1 minus x is equals to 4x plus 4. And then y squared will be is equals to 4x plus 4 upon 1 minus x. To make y the subject, we'll take the square root on both the sides. So y will be is equals to 4x plus 4 upon 1 minus x. We can finally write this as f inverse of x is equals to square root of 4x plus 4 upon 1 minus x. In part B, it is saying that show that 1 minus 8 upon x square plus 4 can be expressed as x square minus 4 upon x square plus 4, and then state the range of f. Now to show this, we'll first take the LCM. So as the LCM is x square plus 4, we'll multiply 1 by x square plus 4. So this will be x square plus 4 minus 8. Simplifying this, we'll get x square minus 4 upon x squared plus 4. Now to state the range of f, the function f of x can also be written as 1 minus 8 upon x squared plus 4, and the value of x was greater than 2. Now to find the range, first let's take the value x equals to 2 over here. So what we'll see is that if I take x as 2, 1 minus 8 upon this will become 2 squared plus 4. So this will be 1 minus 8 upon 8, which is 1 minus 1, which is equals to 0. Now at f of 2, the value of f of x was equals to 0. Now, if we keep on increasing the value of x as it is greater than 2, what we'll see is that 8 upon any of the value will always be less than 1. So let's say if we take 3, 4, or 5 in place of x, 8 divided by 3 square plus 4, 8 upon 13 will always be less than 1. So the answer 1 minus any value less than 1 will always be less than 1. So we'll say that f of x will be greater than 0, as it cannot be 0 as x is greater than 2 and it's not equal to 2. And it will always be less than 1. So this will be the range of f. In part C, it is saying explain why the composite function ff cannot be formed. So if you look at the function f of x was equals to x square minus 4 upon x square plus 4. X was greater than 2 and the range of f of x was less than 1 and greater than 0. Now, when we talk about f of f, it means that in place of x, we have to replace the function f of x. So it means that this will take the values of x. However, we can see that x has to be greater than 2, but the range of f of x is only from 0 till 1. So we can say that the range of f of x does not lie in the domain of x, does not lie in the domain of f. So this composite function cannot be formed. So we can write a final answer as that the range does not have the domain or does not include the domain of f for any of the values of x. Have the domain for any values of x. Again, just to explain this, basically this means that if f of x is taking the x values, it has to be greater than 2. And f of x cannot be greater than 2 as f of x was less than 1 and greater than 0. So this means that we cannot find the function, the composite function f of f.